This tutorial will show you a process to follow to solve any scientific problem. It is the idea here to give you a method to solve any problem. Problems might have open-ended questions, such as find the optimum nozzle dimensions, or the optimum path of a robot, or finding a range of temperature, or simply finding actual tension and forces. In EGR115, most tasks will be develop a program that does one of the following above. But regardless of the problem, it is important to have somewhat of a method, not just to be stuck. This is an everyday part of an engineer's thought process. However complex the problem is, we always have a method to follow. If these steps are properly executed during the solution of problems in this text and all other courses, it is our belief that you will gradually develop an ability to solve a wide range of complex problems. So far, most problems we have solved in high school were maybe 2 or 3 sentences long. However, in college, the problems might be 2 or 3 pages long, so where do you even start? For example, this is a mini project in Mechanical Engineering 408. This is a 400 level class, Clean Thermal Power System. You notice that there is not just 1 or 2 sentences, but rather a lengthy explanation of what the process is supposed to do. So where do you even start? Now, the steps presented here can be found in many engineering books with some variations. Regardless of the topic taught, maybe physics, math, mechanical, aerospace, meteorology, this is a method that is rather common. The first step is, of course, to actually really understand the problem. This is make a list of the given and make a list of what you need to find. Second is a diagram. A picture is worth 1,000 words. So instead of having a list of givens, try to put them in a diagram format, something visual. Third, find the theory. State all the equations that you will need. 4. State your assumptions. Maybe the equations are not that simple, and you will need to make assumptions in order to continue. So state your assumptions before going to step number 5. Step number 5 is actually solving the problem. This is where you use the equations, you plug in the numbers, and you actually come up with an answer. Step 6, clearly identify that result. Put a box around it or highlight it. Make it clear that this is your final answer. As a good engineer, though, verify the accuracy. Usually a velocity, a time, a distance needs to be positive. But that's not only it. Make sure the number that you found is actually plausible for the problem solved. Step number 7 is what is particular to this class, specifically programming. Steps 1 through 6 require absolutely no programming knowledge. Step 7 is when you realize that all the work you just did by hand is lengthy, and you would not like to do it again. So then you jump on the computer and develop a program that will reuse your solution. The coding part is very late in the process. Step 7b. You will never create a code or a program to actually solve your initial problem. The idea is the code will reuse your solution under different scenario, but it will never ever solve the problem in the first place. So doing steps 1 through 6 is actually very crucial to you not spending too much time on step number 7. The key points is that this sequence is a scientific problem-solving method used by many textbooks in a lot of different topics. So remember to apply the steps in order. Trying to skip 1 or 2 steps may seem unimportant at the time, but you will eventually come back to it because you know it was needed. Remember that a program is only useful to repeat solving a problem, not to solve it in the first place. So think reusable. The next tutorial will actually show you an example of all those steps.